Hey everyone, this is FixReef, and today we have an unusual repair. This is my personal battery. I use Milwaukee tools around the shop. I have various needs for them, and this came off of a tool that requires a lot of power. Those of you who are familiar with those tools and they see this high output HD12, you already know what this is going to be about, because these batteries have had issues from the day that they were released. So it finally hit me as well, because I use this battery sporadically. Again, it's a massive, huge battery, and it's a 12 amp battery M18, and it finally failed on me. So if you see here, there is a status indicator. The status indicator goes up to about 3 bars instead of 4 bars. Never goes to 4 bars. When you try to charge it, it charges very quickly. There is a problem here. This battery is dying, and I need it for more than just 5 minutes that's able to run my equipment. So today we are going to attempt to repair this. Now, those of you who have had problems with these batteries, you already probably saw videos on YouTube here and there that talk about rebalancing these units, taking it apart and just trying to charge separate blocks of cells so that it goes back to 100% charge. But ultimately, this is not the right solution for this, because what we need is a battery that lasts long and that's reliable. And currently, this isn't reliable. And rebalancing is not going to fix this problem permanently or long term. And for long-term solution, we are going to have to fix the root cause of the problem. And the root cause of the problem for these batteries is the original Samsung T40 cells. When they were released initially in 2018 or 19 or whatever, they had problems. They were able to produce high output, no doubt about it. One of the very first cells that were able to do something like this back in the day, but they didn't last long. And that's what finally happened to this battery and to thousands of others out there. I have not found a good video online that shows how to properly repair this without rebalancing and by replacing all of the cells for the cells that will do at least as good of a job, if not more. So I figured I will record a video for myself. Now, let's set this aside and let's take a look at what we're going to be replacing them with. So these are brand new cells. These are the Molicel, what is it? P50B. Now P50B is one of those things that is supposed to be better than the T40s that Samsung used to make. It still provides high output, but it also does higher amperage. So this is about almost 5 amp battery, whereas the original T40s were, I think, 4 amp batteries. They also they can give a lot of power out quickly. That's what big tools need that require batteries like this. That's what I'm going to install in this battery in this repair. I will do so in a way that is least disruptive. I like the way how Milwaukee makes these cases. They are nice. They have rubber bushing. They have strong plastic. Everything about the case is very nice. I want to keep it that way. And everything about the inside of this is also very nice. So we're going to go ahead and try to preserve as much of the original stuff by replacing only what's broken. And that's been what I've been doing for years, helping you guys out. And I think this falls into the same category. All right, so first we need to take this battery apart. It's not really all that hard. It requires a couple of different tools. I think there are T8s on the bottom here, and these are regular T8s. They come off fairly quickly and easily. Now, this just holds the bottom, but we also need to get the top off. And to get the top off, you have to use a security star type T10 Torx wrench, right? Because you cannot reuse the regular one. The difference is, I don't know how much you can see here, but there is a tiny hole in the middle of the tool here that fits in there. That for some reason Milwaukee decided that that it's we're too inexperienced to be able to take these batteries apart ourselves. Maybe we can kill ourselves with these batteries. I don't know what's going on. So they decided to make it harder, that you need to get an extra tool. Well, I do repairs, so I have all the extra tools that I need. So it's not going to work on me. So there are two long screws and there are two short screws here. They're kind of self-explanatory and hard to actually mess up. The short screws go in the part that on the side rather that is kind of small over here. These are the short screws, and these are the long screws over on the other side. See, they're about twice as long because they have to go all the way through the casing on the other side. Again, I don't know how much you can see, but there is a little gimbal in the middle of that screw that would prevent your regular T10 from going in there. You have to get a secure or a tamper-proof, I guess, screw driver to be able to remove those. Okay, so we got the case unscrewed. We should be able to just turn it and pull it out. All right, the battery itself is pretty tight in there, but nothing crazy. And the battery comes out, and that's what it looks like when you take it apart. Now, from this point on, we have to be careful. This battery is actually fairly well charged. I didn't discharge it, so it still shows 3 bars, and it still packs quite a bit of a punch. So we don't want to short anything here. Now, if we look on the side here, that's where it's kind of sort of interesting as far as cells go. We have 3 banks of cells, right? So this is bank 1, bank 2, and bank 3. Bank 3 is kind of smaller, half the size. So there are 6, 6, and 3 cells. So a total of 15 cells, producing again about 20 volts and about 12 amps. So the same on the other side, except that of course we are running them in kind of parallel and in series. So the short one's going to be over on this side, and these two are over on the other side. What's really good about the Milwaukee batteries in general is that their way of managing the charge here and the way how they release the charge. This is fairly beefy. So the control board, pretty big here, contains all kinds of things. In the middle, you have a whole lot of copper that goes on top and also underneath, right? So that's holding MOSFETs and cooling them off as the battery discharges or charges, so that it doesn't overheat. So we don't want to kind of disrupt any of this. So my plan for this repair is to keep as much of this intact and only remove the bad cells, or all of the cells for that matter, in this pack. For this, we are going to hold this nice conductive brackets over on the sides of these batteries that really create all the conductivity for the batteries. We want to keep them as intact as possible. They're going to be soldered to the board, the contacts here. We're not touching any of this whatsoever. We are going to repurpose these brackets, all 3 of them on this side and all 3 of them on this side. And the only thing we need to do is we need to very carefully remove the batteries. Obviously, you cannot just remove the batteries. You have to disconnect them, and to disconnect them, you have to disconnect the tabs. The tabs over here are welded to the batteries pretty good. So we need to carefully cut. Here's my plan anyway. This is how I like to do this. This is how I like to do this. Is I cut the tabs pretty close here, right in the middle, all of them. All right. Then I'm going to carefully lift the brackets up. Then I'm going to remove the whole assembly of the PCB with the brackets entirely off of this unit, exposing just the batteries inside of the casing. Then I'm going to take the casing apart. I'm going to remove the cells. I'm going to replace the cells, and then we are going to add these new brackets over here, pieces of nickel steel, to connect the new and weld the new cells together. And we're doing so that we can preserve the nice brackets that are factory brackets. So let's get to it. Again, the battery is charged. If we short any of this, we are going to cause some issues, some fire. So we're not going to do that. So we're going to be careful in basically cutting off all of them one at a time. I'm going to start cutting off this bracket over on this side and this bracket over on this side, because this is where my power goes into the charging circuit and eventually over here. So I want to cut them off of the cells right away so that I reduce the chances of something shorting and actually blowing up the control board. Once that's off, then we can worry about the rest. So I'm going to speed things up here so that we quickly remove all of the stabs. And the other side is done. So now my mains are disconnected. Now we have to just worry about the other two banks. Okay, so just like that, fairly quickly, all of the cells have been disconnected from the brackets. So now we just need to gently bend the brackets away. In case I missed something, I need to go in and do another cut. Looks like I missed a couple of things here. There you go. Probably better to do it with plastic tools. If you're new to this, I would definitely recommend plastic tools for this. All right, our mains are disconnected. Now, as for the rest of the brackets, see, nice and easy. And they just snap off, but they still stay on the main board. And that's the best part about this approach. You do not mess with the main board. You do not have to reconnect these brackets back on. All right, so this is the most critical part. We now need to lift it off. To lift it off, we actually need to remove some screws here that hold the main board. So I think that, let me see, this will work. Need a T8. Again, it's best to mess with this after you disconnect the mains, so that you don't have to worry about accidentally shorting something and breaking the main board. So notice how there are two screws here, the longer one and the shorter one. The longer one goes into this plastic, the shorter one goes into the board itself. I think now we should be able to just lift it up. There is going to be another annoyance in the form of this thermal sensor. So it needs to be lifted too. There you go. And just like that, we have the board with all of the brackets still intact and usable. I will need to maybe go and carefully make sure that the edges are not rugged, but other than that, it looks really, really good. So we're going to set this aside for now and focus on this. Okay, so what's left here is, again, this plastic that the cells are in is again held by security screws. So we need to remove those. And 4. All right, so all 4 screws are the same size, so I don't have to worry about what goes where. And that's it. Before I take this off, hopefully you can see this, but the plastic casing has markings where the positive and negative cells sides go, right? So we cannot mess it up. Every single cell is labeled with either plus or minus, so we know what goes where when we need to put the new cells in. So now we just need to carefully. Oh, there's one more screw. I'm sorry. Forgot about this guy. So 5 total, and all of them are the same. All right. So that's it. Now we can take the cells out. Now these are not the 18650 cells. These are bigger 21700 cells. These are this type of cells that Tesla's, Model 3 and such, Model S run on, not the Cybertrucks. These are bigger cells. And there are 15 of them. Not much to casing otherwise. Let's take a quick look at cells themselves. So these are Samsung 40T. There is a history on the Samsung 40Ts. Again, these are not marked. And because they're not marked with the generation of this means that this is the very first generation that Samsung made. And this is why I'm having problems with this. I don't know if the later ones are better or not, but the earlier ones had problems. So we are not going to use them. I'm probably going to use them, well, the ones that are good. I'll have to check all 15 of them. And those that are good, I'm going to probably reuse in my other projects. But for this battery pack, all of this is gone and will be replaced with mollicell. These days, the equivalent batteries that Milwaukee sells, which is the 12, what is it called? 12, the forged ones, 12 amp hours. They use AM cells. They're tablets. They're supposed to be the latest and the greatest in the technology for batteries. I could not source enough of the AM cells out there. It's very difficult to find. So I just got mollicells, which are a good brand to use for this, I think. All right, so this is my mollicell stockpile, brand new, completely brand new cells, and we're going to put them in. Again, because everything is properly labeled, it's fairly easy to figure out what goes where without actually taking pictures. So positive, looks like positive, positive, negative, 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 positive, 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 and a bunch of negatives. And the last row is all positives. Okay, quickly verify with what we have here. Row of positives, negatives, positives, negatives, and positives. Looks good. All right, the pack is fully seated. Just need to assemble it with the 5 screws that came with it. I'm just going to have all 5 of them kind of mostly in there and then tighten very carefully, one at a time. And that's it. Okay, so the new pack is kind of assembled. Now we just need to put all of the original components on and put it together. Okay, so the way how we're going to install this is pretty easy. So there is an indicator. So this will only get, so the board will only seat only one way. You cannot make a mistake. Another good indicator is that there is a little opening over here for the battery. This is where our thermal sensor goes in. So if you look, the thermal sensor is right here, so it needs to be on this side. All right. Once again, very carefully place the board on without moving it too much, because you don't want anything crossing, because these are not fully charged cells, but they came charged from the factory to some degree. So we may need to make sure that they don't cross where they shouldn't be crossing. So without touching the mains quite yet, we're going to position the thicker brackets on both sides so they're not flapping all over the place. And finally, the main brackets. Snap right in. Snaps right in. And just like that. So before I go any further, I will secure the main board. So that's not going to go anywhere. Again, there is a longer screw and there is a shorter screw. The longer screw goes in this plastic piece. And the shorter one goes straight into the PCB. Very good. Now I don't have to worry about shorting anything while installing, because everything's disconnected. Now we need to worry about how to connect our cells. I managed to break a couple of pins here, so one of my brackets is a little loose. That's all right. It's mostly in place. Okay, so what are we going to do about assembling the actual circuit of these batteries? So we cannot weld, or I guess we cannot solder to the batteries themselves. That's never a good idea. So we're going to spot weld those. However, we should be able to weld just fine to those brackets. So I'm going to cut strips of nickel to go across each of this bracket, to go into each of these batteries everywhere. So I'll need a bunch of these pieces. So then we're going to solder them onto the brackets quickly without melting the plastic. And then once they're soldered, we're going to spot weld the ends to the batteries. Let me go cut some nickel strips and I'll be right back. All right, so I cut the strips. Now we're going to need to attach them. So first, soldering. All right, so to do this, to minimize how much we need to heat things, we're going to do this on strips first. So a little bit of flux, small blob of solder right in the middle, because these are the longer ones. This is going to create a nice surface. All right. Now, if we were to go back to our pack, so let's just say that it's going to go on here. I already put a little bit of solder on there. Oh, I already put a little bit of flux on there. So let's put some solder on here. All right. Now we should be able to put our strip. Maybe hold it in place a little bit. And that should be enough. Nice and easy. So why is it that I'm allowed to do this? Some of you purists are going to be like, oh, you're supposed to spot weld it. And no, I don't have to. Spot welding is important for batteries themselves, for the cells, because if you in order to solder onto the surface of the battery, you really need to heat it up. You heat up the battery, you degrade the battery. Nothing's currently attached to the battery whatsoever. So I can heat up these brackets all day long without any damage to anything. Why am I going into trouble of soldering all of this? Because next time my cells fail or get used up, I don't have to no longer destroy these brackets. All I have to do is just apply some solder, remove the strips, put the new ones on. The brackets remain the same. They're never messed up. And that's the logic. Anyway, let's do, I guess, this part, assemble this, and then we'll move on. So for this, we'll need 5 more longer strips and 3 shorter ones. Okay. For the long ones, we put solder right in the middle. For the shorter ones, we have to put it on the side because the other side is going to have the battery hookup. Otherwise, the same process. Apply a bunch of solder onto each of them. And just like that, One side is done. Now we'll do the same to the other side. All of the strips are in place and they're secure. Just because I want the work surface to look clean, I'm going to wipe all of the flux off. Why leave all of this sticky mess in place for the next time you yourself is going to be fixing this again. All right, almost looks like a professional. Okay, so now all we have to do is just weld strips to the batteries, and I think that this pack is going to be all done. Well, like it or not, but everything is welded. I have no idea if this battery or any of these batteries hold charge. Let's press a button. Let's find out if there is any charge. None whatsoever. Completely dead. Well, assuming that I did everything right, we should be able to plug this in to the charger and it should start charging. Let's find out. Okay, so plugging it into the charger didn't help. However, it did reset, and now it's blinking a single light. What this means typically is that we have a battery that's not fully charged or not charged enough for the charger to pick out that this is a valid battery. So what we're going to do is we're going to apply charging current to it and see if this is going to fix the issue. It's consuming a lot of amps right now, so off of the power supply. So I imagine that that it is charging at least somewhat. Okay, the battery is showing about 18 volts now. Probably not sufficient. Needs to be closer to 20. And look at this. I'm not sure if you can see, but it's red. And the indicator on the battery is that it's, 2 bars charged. That's promising. Unplug. And let's reassemble. So the easy part is now. It goes in. Oops. The cover goes back on. And real tiny screws. And the unit is now assembled. All right, let's see. Kind of hard to see, but 2 bars, 2 solid bars, nothing's blinking anymore. Plug it in the charger. The red light comes on right there, and it's going to now charge quite a bit. And so this is it. Look, we've upgraded, we essentially made pretty much a forge out of this old unit. The old T4, Samsung T4 batteries failed. I'm going to go through them and sort through them and test them on my tester, find out which ones are good, which ones are bad, maybe use it for something else. But those cells were not very good quality, and they were upgraded with the new high quality 5 amp cells that's going to give this huge battery a whole lot more power. I did this so that I would be able to in the future replace cells easier without damaging components inside. I've reused everything that I could. I've reused the original brackets, the original case, the original charging board, and so on. You can go online and you can buy a Chinese knockoff kit that includes the case, the charging board, and those brackets, brand new. And you can assemble a battery like this yourself. but I do not trust Chinese cheap parts. They're not exactly cheap. They're not cheap. So their boards are not original to Milwaukee. They're Chinese knockoff boards. They don't work the same. They don't charge the same. They don't maintain the battery the same. The case that they sell doesn't have this nice finish with rubber boot, with strong plastic. No matter what you do to this plastic, it doesn't break. And who knows what they made those brackets out of. If they made them out of steel and you put high output battery on it, it's gonna overheat, it's gonna burn. I don't want to mess with this. These batteries pack a lot of power. So I ended up reusing all of the original Milwaukee parts. The only thing that I really added was the batteries, I guess the cells themselves, and nickel strips. I went oversized and overboard on those strips just to make sure that they can carry the current that this battery is capable of providing and producing, and I think I've succeeded at that. Well, this was Fix Reef. This was also an unusual repair for me, but something that I do periodically as I maintain my equipment. Hopefully you found it interesting and useful. If you did, please like and subscribe. If you're new to this channel, if you came here to see this, how this repair works, and you are interested in future repairs, please like and subscribe. Otherwise, everyone, thank you for watching, and I will see you next time.